I go back onto the mobile phone. Some things are just easier to show you using this camera, but hopefully when we get a proper video set up, we can just do continual recordings and just change between cameras. So GPU's got to go. We can't find the short circuit. We've removed all the capacitors on that rail that we can find in this area, which is where I thought I could feel something getting hot, but you know, it was not getting very hot, and maybe I'm just wrong. So first thing we need to do to remove the BGA is get some flux behind it, and I find this Amtech flux. I've used various liquid fluxes, but I find this is the best to use. So what I'm doing is here, I'm actually just putting a whole, I don't know if you can see it, like a row of flux on the edge of the chip, and I'm going to get the hot air station, and I'm just going to warm that up, and the flux will turn to liquid. Some of it will run down over the chip, but some of it will actually run down behind the chip. Okay, that's that done. And then you're going to swing it round 90 degrees. Same again. This flux is almost out. I think I need to get another syringe. Keep that stuff in stock, you know, don't just have the one that will run out when you most don't want it to. Again, just lay it down. So yeah, so keep yourself a few spare syringes, and then when you get down to the last one, go and order some more. Let's see if there's enough left in this one to actually finish this job. Yeah, still something like that. I can see that some of this is getting down behind the BGA while I'm doing this. Yeah. A line of flux across the top. Because it's quite warm now, it's starting to run down by itself. Then just warm that. And normally I go twice around the board while I'm doing this. So again, we'll come to the top. We'll just give it a little bit of a warm. With a bit of luck, you might have seen that actually disappeared. Again, we'll go to this side. We'll more. And this is just about empty, but I think we'll have enough. You can see myself, that's gone down behind it. Yep, that went down. And the last side again. And this must be the last of this flux by now. It's a smidgen left, but I say I've got 3 or 4 more anyway. There we go. So that's a good amount of flux down behind the BGA. So there's various equipment you can use for this. I use a BGA Rework station. I know some people do this on hot air, and there's nothing wrong with that. Use what you've got. A preheater plus hot air should do it, but I use something a little bit more sophisticated than that. So we're going to go over to the BGA Rework machine now, and we're going to get this GPU off this board. So this is my BGA reworking machine. It's a semi-automatic machine. It's 3-zone. So basically, these down in here, these are like hot plates like you would have in an oven, and that basically is a preheater. Underneath the board, you probably angle you can probably see down there. There's a hot air nozzle. That's the bottom heater. And up here is the top heater. In the centre of that, you can probably see a little rubber, that's the vacuum pickup. This machine actually has optical alignment as well, which allows me to align BGAs when I'm fitting them onto the board. But I don't use that a lot, to be quite honest. From experience, I found quite often you really don't need to use that. You think you do, and then really you don't. So let's just go into the machine. And we can see this is where we set the temperature profile. So the beauty of a machine like this is you can program it with what's called a profile, which is a set of temperatures to heat the board up, and then it will do what you've asked it to do. So really you can sort of sit back and let this machine get on with it. So what I would normally do first, can you see the laser dot in here, yeah? Move temperature probe. That's in the centre of the chip, so that tells me where the hot air is going to come down the top nozzle. But what I often do first is I'll just go into here, and these options, so remove as desolder, mount as basically how the machine, if you're using the optical alignment for position. Have a semi-auto mode I don't really use, you have a manual mode, weld as solder, back to remove. So if we put this onto manual, I now have a lever here, and you can see if I hold the lever, I can bring this nozzle down. And what I'm just doing now is I'm having a look to see if that's going to come down to the right place. Is the board centered? But sometimes, depending on the thickness of the board and the height of the chip, the laser dot isn't particularly accurate. You know, the higher the board, that'll sort of move to one side effectively. So the nozzle, and as you can see, it's 41 by 41 millimeter, and we're just going to stop that there. And now we can have a look to see if that chip is centered under there, and if it's not, we can adjust it a little bit. I mean, it's pretty close, to be honest, but let's go a little bit the other way. Let's just move it back a little bit. Yeah, that's about in the centre there. Come down the side, front to the back. We have a light we can shine in. Yeah, that's pretty good. So I'm happy now that that is in the right position. So I'm going to go to stop, and I'll now lift the hot air back up again into its home position. And once it's done that, we need to select a curve. A curve is basically a pattern, a profile. So we go to curve select, okay, and we choose curve. And then here, I've programmed various curves and give them names. Lead free 1, 2, 3, lead free stubborn for things that already get off. Lead free LGA, that's for processor sockets. LG gamer, that's for processor sockets again, and gamer mounters for resoldering them. GPU remove. So this is a profile I set for GPUs. Sorry, we go back in. I've shown you areas I didn't select it. GPU remove, okay, confirm. So that's now told us the curve we're using, yeah, and we can come back. So this is a profile that I've programmed myself. When you buy these machines, they come with some pre-programmed, and you try them first and they work, and then they don't work because they're not hot enough for some boards, and gradually you play around, and then you get motherboards, gaming boards require more heat, so you'll program one for that, and so on. And to be honest, while you're doing this, you're going to destroy a bit of stuff. I don't think there's any way around that. It takes practice and a bit of time, so it's best to get some scrap boards first and just try and remove stuff and play around with profiles until you can do that reliably. So anyway, we have a profile for this. We've got flux underneath the BGA, you saw me do that. So we're now going to change the mode here to remove, and we're going to tell the machine to run. And from this point, really, you can sit back and relax. You can go and make yourself a coffee. But to be honest, at first, it's probably a good idea to keep an eye on what the machine is doing, because you have an emergency stop down here if something is going badly wrong. The temperatures are up off the scale. So you see that's detected the chip. It's dropped down there. You probably can't see very well. It's hard to see, but the little rubber plunger is now on the chip. And the profile started. We're 11-12 seconds in. And what we have here, the dark blue is the infrared heaters. That's these plates here. The turquoise is the sensor. That's the little sensor I put by the chip. Up temperature is the top heater. Bottom temperature is the low heater. You can see a graph here now forming. So you can see that the infrared heaters are run slower. It tells us up here it's 79 degrees. And we can see the temperature of the two nozzles and the temperature on the board. Now, what I found is that you'd expect lead-free solder to melt at around 230 or something like that, but as I've discovered, it doesn't. I would not say it's not the case, but the probe isn't really reading a good, an accurate temperature, because it's measuring the temperature just below the hot air nozzle on the surface of the board, and you need to get heat into the board, into the ground planes, before that chip will desolder. So you will find out if you have a machine with profiles, you need more heat than you might expect. This, you can see there, the nozzles are now coming up to 199, 200, and it's going to hold that for so many seconds, maybe 30, depending on the profile. And you'll see that the turquoise is just crawling up. That's the sensor temperature, and this is allowing time for heat to get into the ground planes. And the way the profile works is every so many sockets it steps up again. Here we go. The bottom heater, the big hot plates are on a gradual warm up. They'll reach 200 and then just level off at 200 and go no more. With 188 now. And again, the hot air top and bottom is now at 240. Yeah, 245, and it's leveling off again. And again, we allow time for the turquoise one to gradually creep up. That's now at 211, so it's not yet hot enough to desolder. We're now 164 seconds in. The entire profile takes about 300 seconds, this one, so what's that, 5 minutes to remove a GPU. If you can see down by the GPU now, you might be able to see that the flux is bubbling out from under there now, so the flux is liquidizing and pushing air out from under there basically. Up we go again, another ramp up, so we now top and bottom air at about 320. Okay. The probe temperature now is at 267. Now you're going to say, come on Rich, that's hot enough. From my experience, that probe is not reading the core temperature of the ground planes on this board. And you need to get above that, probably near to 300 before you've actually got enough heat in to actually desolder it. So it can be a little bit deceptive. Some people use much more basic equipment than this. Some people use hot air, a quick 861 with a stand to hold it. Thermocouples. What you use, I guess, depends A, on how much money you have to spend on the equipment, and B, what works for you. There's a guy on Bad Caps Forum who uses an infrared machine, and his is quite a bit cheaper than this. I think it's a Jovi, and generally speaking he has more success. He's been teaching me. Maybe that's because he has a lot more experience than me. It's now starting to, you can see the smoke now coming off from the flux on here, and we're 260 seconds in now, so we're getting close now to temperature. The probe now is a bit over 300, which you may think is very hot, but as I say, that doesn't really read an accurate temperature of what's going on underneath that BGA chip. Making little crackling noises, sometimes you'll hear that. When this reaches the end of the profile in about 15 seconds, it'll make quite a loud beep. Don't worry too much about that. The first few times it certainly makes it jump. We're going to get there any second now. And then it's going to remove that chip crawlers off the board. And there you go. With a big puff of smoke, the BGA is now off the board. Okay, so what's going to happen now basically is the machine is going to cool down. When that BGA is cooled down a lot more than that, I'm going to use tweezers and just take it off that suction and put it on one side. So now we will just let this cool down. You can see it looks like a good remove we have there. and when the board's cold we'll have a look to see what the results are. So as you can see, we've removed the GPU from the board that had the short circuit on it. So first thing we're going to do is have a look to see if the short circuit's still there, or was it the GPU. So the short circuit was from ground to this coil, and the 2 ohms has gone. So obviously the GPU was the cause of the short. So that's good. Now you might have noticed on the video I had these on my BGA machine, and the great advantage of the BGA machine I use is the fact that it has preset profiles, so you can set a profile and it's kind of like, you know, fire and forget. You just tell it to do it and it does it. The big disadvantage of that machine is exactly the same thing. It has preset profiles and it's fire and forget. And the problem is that the profile you use is a bit difficult to determine. I mean, the profile I used was for graphics cards, and the last ones I was working on were GTX 780 Ti's, and it was fine. But on this one, if you notice towards the end of the video, it started making a bit of a crackling noise, and I know it sometimes does that. But I know full well when it does that, it's because it's too hot. So in this case, because the thermal mass of this was less than the 780 Ti, the profile was too hot. But at this point, there's nothing you can do about it on that machine. You know, it's doing it, and that's that. You can hit the emergency stop, but then you've got to start all the way again from the beginning, and it's already got too hot anyway, so you're just going to do like another cycle. So what basically happened is, let's have a look at them under the microscope and see what the results of that reworking was. One moment, let's go over to the microscope. Okay, let's see what happens. So this is the video card. Can we zoom out a bit on this? That's it. So this is the video card, and quite typically you get blobs of solder when you remove a BGA of any sort, and that's what we have. But other than that, it looks pretty clean. Yeah. Underneath the board, all the components are still in place. Nothing's moved. There's a couple down there. This is where we were desoldering components. Okay, so obviously they're not there. But that looks okay. So okay, that's probably survived pretty well. In a minute we'll clean it up and we'll have a look. The problem was the GPU. You see this GPU? It's now like bubbled. This is what was making the cracking noise. It got too hot. So you can see along here it's broken away, and up this side here. See like this? Yeah. That's dead. But to be quite honest, it was dead anyway. This is where the short was. So the fact that we've trashed the GPU isn't particularly important. Looking underneath it, it's the same sort of blobby thing, but I've just noticed down in this corner here that we might have actually, these little brown ones, it might be that we've damaged the board as well. Let's have a look on the board. That sort of like brown, that can often be where we've like lifted pads. So what you're seeing is the upside down, the upside down of the pad stuck to the ball in one corner. So it may be not only did we get it too hot, but we didn't get a good heat. And in that case, it's probably come from around here. But what we'll do, let's have a look. I'll show you how to clean one of these up first, and then we'll clean off the old solder. We'll do the same with the BGA, even though it's trash, just so you can see how that's done as well. I think the easiest with this is actually to go back onto the shall we use the microscope? Yeah, go on, I'll use the microscope. This can get a bit smoky, shall we say, from the flux when you're doing this sort of thing. So what I normally do is I have you'll see it on the desk cam in a bit, but I have just an old computer PC cooling fan with a 12-volt power supply attached to it, and I can just plug that in. I don't know if you can hear that, you might do. And all that does is blow solder flux fumes. Fumes is not solder, it's flux, yeah. It doesn't vaporise the lead, you will not get lead poisoning. But the flux can get up your nose and irritate you a bit. So the way to do this, camera's froze, hasn't it? One moment.
Seems to be like spikes when you pull stuff in and out. Seems to do that. Let's see if we can just get it back again. Yeah, we've got it back again. Okay, I just have to restart it basically. Okay, so the way to do this is basically you get a big chunky BC3 tip, yeah, and you get some flux. Okay, the first thing we do, I'll just do this area under the microscope, then we'll do the rest of it under the bench camera because it's easier. We get plenty of flux in the area we want to work, yeah, which is here. What I'm going to do is now we get some solder, a nice big blob of solder on the end of the tip, yeah. So we kind of like fill it with solder, and we let that blob, when it's big enough, drop onto the board, yeah. And now I'm not pressing down on this board. I'm literally floating that blob of solder all around this area of the board, yeah. And it's picking up all the old lead-free solder. So obviously that blob gets bigger and bigger as you do this. So when it's too big, you need to move it away. Just stick it onto your foam, and then we just go again. Before I do each area, I need to put flux on it. So I'll just go around this one a little bit more. You can't do this unless there's flux on the area. So, well, let's stick under the microscope. Why not? It seems to be working well. So. Just put some more flux on this thing. I'll just go all over it so I can move around it. What will happen if you haven't got enough flux in an area? Your blob of solder will stick to the board, and then it's just a matter of putting some more flux and coming back with the iron. So let's just go around there, fluxing this, and you can't have too much, but you don't want to flood it with flux. If for no other reason you've got to buy flux, you know. So let's move on again into the area, the next area which is here, and we'll do the same thing. So big BC3 tip, lots of solder. There's another tip called a BC3M and a BC2M that kind of have like a little pit in the end of them which hold more solder, and they are meant for this sort of work. But I found the straight BC3 does just fine, and it's considerably cheaper. These tips are about €3 or €4, whereas the M is maybe 10 or 15 euros. Okay, so it's another area done, yeah? Well, let's keep going. You've got to understand that BGA rework is not, well, it is an exact science, but getting the exact science exactly right is not easy at all. When you're using even the equipment I'm using, it's not necessarily easy to do that. And I'm also going off the board, so I'm not showing you. But quite literally, I'm just hovering this. It's just touching the board. You might be able to hear it, but it's not. I'm putting absolutely no pressure on that whatsoever. Yeah, I'm just letting it either hover over or just sit against the board. So here's the last bit we haven't done, I think. So again, feed a lot of solder in, get your blob, and just let the blob work its way over all the balls. Yeah, that's looking like I've probably removed most of the excess solder, but now we have like bits of leaded solder all over the board, and we need to clean off as well. We need to get these flat. So the way we're going to do that is solder braid. Okay, so solder braid. This is the solder wick type, yeah. Part number 804-5, size 4. This is the sort of braid you want for this sort of work. Like the more regular, thinner braid, the cheap stuff, doesn't do it so well. You need something with a good amount of capacity to hold solder, yeah. So what we do is we cut about a centimetre or so off, and the reason we do that is because if we're holding the braid in the tube and moving it around, heat is being transferred up here, so it stops you getting the proper heat into the actual solder job itself, yeah. Also, to do this, it's probably a good idea just to get the hot air and just give the area a bit of a warm. I'm not getting anywhere near enough to melt the solder. I'm just gently warming this area of the board, yeah? A little bit. That should do. I've just warmed it a bit. We could put a thermocouple on, but I've done this enough times not to. So what I'm going to do is I'm going to add a bit of solder to here. Now this might seem counterproductive, but by putting a bit of solder on the tip, I get a good contact onto this. Just a bit, and I get a good contact onto the braid, yeah? And then again, I'm not putting any pressure on this. I'm just letting that braid move around the board, yeah? Just keeping a flat connection against it. Gradually the braid will fill up with solder. If you go into an area where you're moving too fast, it's not hot enough, the braid will stick. If it sticks, don't try to move it. Straight away, lift your iron. Put another little bit of solder on your iron and come back on the braid. Hold it for a second or two, and then try and move it again. If you don't do that, you'll be lifting pads. Yeah, and we don't want to be lifting pads. If you kind of lift pads off this, it's kind of game over, really. I mean, I have seen people fix them if it's just an odd one, but it's not something you want to be doing, I'll tell you. Okay, so you can see that braid now is nice, full of solder, so we'll get rid of that. And we'll cut another bit of braid, same sort of size. And once again, we're back on the board with a bit of braid, yeah. It's also quite handy to put a little bit of flux on top of the braid like that. And we're coming again, yeah. So we're going to do the same thing. There's the braid. Clean the end of the solder now so it's nice and clean, yeah. A little bit of solder on the end of the bit. Just a little bit onto the blob of flux. And now we can go again. Yeah, no pressure on the board at all, no pressing down on the soldering iron. If it wants to roll off like that, I'll just let it do it. And gradually move into the area that you need to clean. Yeah, see, like it rolled over. Just let it do it. Don't worry about that. That was stuck slightly there, so you just wait to get a bit more heat into it. And again, we just gently let it move. That's getting full of solder now, so we'll take that one off the board. We'll shove it out of the way. Same again, about a centimetre of braid, or just a little bit more on the board. Bit of flux onto the braid. Yeah, bob of flux in there. Same thing, clean your tip. Come in. A little bit of solder on the tip and onto the braid. Just give it a second while it heats through. And we can continue. Yeah. That's just starting to stick a little bit. So what I'll do is, I'll get the hot air, and once again I'll just warm this area of the board. And not anywhere near enough to melt the solder, just enough to help the heat transfer into the braid and into the board, yeah. And we'll come back again now. Little bit dab of solder, little dab of solder on there, on the braid, yeah. Just give it a few seconds. When it starts to smoke, you know it's basically right. Okay, so that bit's full of solder. And you can see how this is going, can't you? You're just basically doing this into each area of the board, yeah. So once again on there, bit of flux, clean the tip, bit of solder. I'm using the 0.7mm solder for you because you want to get a reasonable amount on. Wait till it melts in, and again, just gently under its own weight, let it just go over the board. You can sort of feel where it's done, because when you're doing this, because you're putting no pressure on, you can kind of feel through the iron that the texture. This is where this type of iron I have, where you hold the iron near to the tip, is a great help. So we're over here, we're to the edge, and we back up this side. You can see where they've done, can't you? Because if you look, you'll see like the ones where you've done are like flat and silvery, yeah. The ones where you haven't done it still look like little balls here, yeah? So you can clearly see where you've worked and where you haven't worked. And we're back where we started now, so we've basically done now, it's just these in the middle. So once again, it's exactly the same thing. Gently, gently. And that piece is full of solder. So that is pretty much, now if you look at it, you can see a few. I can see a few. There's a few here that look like balls, yeah? So we need to do that area again. Same thing, about a centimetre of braid. The trick to this is having the right braid. When I first, I mean, somebody told me how to do this, and when I first started to do this, I couldn't do it very well. And it's because I was using cheap braid. The braid wasn't thick enough, wasn't absorbent enough, basically. Also, I wasn't doing this where I'm adding a little bit of solder on the end of the iron before touching the braid. That's something I kind of learnt myself to help. You're doing this, you can kind of like feel your way, you know. I'm just like glide around, and I can feel some areas where it's just a little bit rougher, and that's where I know there's still a little bit of like, you know, where the balls basically. Yeah, there was a few there. Okay, so that's basically cleaned up the board. Okay, now we will go over to the desk cam again. Okay. Okay. Yeah, can you see how I was working now? There's the fan, which was just blowing the flux fumes away from me. Okay, so that's the PCB done. So let's now clean that up. Yeah. So what we need is a paintbrush, like a thick brush, not exactly a paintbrush. I'm not sure what you would really call that. And some isopropyl. This is stuff I've actually used before. I tend to like keep the used stuff in the bottle, and you can use that to get the worst of this off, and then use some clean fresh to finish it off. The reason I do that actually on this island, it's not easy to get isopropyl alcohol. It's not easy to get it here. You see where I've left those two bits there stuck to the board. Yeah, they just held on by flux, nothing else. I'm not putting a lot of pressure on this, I'm just letting it soften it up itself, yeah. It's dragging a little bit like this, so just let it do its job. Yeah. And then we can see. One moment. Okay, sorry about that. I think it was just a sales call. It's great, you know, that is living in Spain. One moment. Everybody wants me today. Okay, yeah, it's a good thing that, you know, actually living in Spain and being English is when you get, and you're pretty well sure it's just a sales call, you know, everybody spam calls, something you don't want, they're trying to sell you something. I understand enough Spanish to know when they're trying to sell me something. So what I then do is I just tell them I don't speak Spanish. I'm not a fluent Spanish speaker. I can get by usually, or at least I can understand what they want. But yeah, that's great, that, you know, just pretend you don't speak Spanish and then they just go away. That's one of the advantages of living in another country. You'd be surprised, by the way, the number of Brits here who don't speak Spanish. I mean, and yet you can guarantee those Brits here who don't speak Spanish are exactly the same Brits who complain about people moving to the UK who don't speak English. Yeah. I mean, how hypocritical is that, you know? Okay, so right, we set the world rights a little bit on that one. Let's just clean this up now. So I've cleaned that up. Yeah, that's got the worst of it off. What I'll now do is I'll take some fresh, clean isopropyl alcohol. in my little plastic thing here. Oh yeah. We can give it another clean with that, and then this when it's used will go back into here, and it gets used again. Yeah, that's my way anyway. If you're somewhere where you know you can get stuff easily, it's not a problem because it's not expensive and you don't use a huge amount of it, you know. But for me, I have to kind of conserve it. Normally, the way I get this is when I've got friends or relatives coming over from the UK, and I say I'll order one off eBay. Can you stick it in your suitcase and bring it to me? But obviously, with all these travel restrictions at the moment, that's not possible. Or the same again, if I go over to the UK, I'll bring stuff back. But once again, it's not possible. Okay, so let's clean that up. So this stuff now will effectively go back into my little jar view stuff, yeah, and we continue with it. Right, let's see what we got now. So let's clean all that off there. Let's take this back under the microscope and let's have a look to see what we've got now. Yeah. How's it looking? Yeah, they're looking good, aren't they? Nice and clean. You can see where I've missed one there, but it's not a problem. But now let's have a look at this corner where we thought we might have lifted some pads. We might, yeah, we have done. This one's trashed. Not only did we get it too hot, we didn't get enough heat into this corner. You see, there's on there with a track going to it, yeah. So that's trash. That's scrap. That is. If it was an expensive board, yeah, you might want to try, but there's too many. There's another one here gone. You can generally know when that's happened when on your BGA you find something like that, yeah. Those brown things, that's like the arse end of the pads that you've ripped off the board. The way you clean BGAs, by the way, if you haven't trashed them and haven't trashed the board, is much the same. You just put flux on there, yeah, and you get the big blob of solder on the end of your soldering iron, and you do the same thing. You just nice big blob, and you let it hover over the BGA, yeah, cleaning up the area. See, that's stuck then. That's because I haven't got the BGA warm enough. You'd use a bit of hot air, just get a bit of heat into the thing, yeah. Well, that's how, same method, that's how you would clean that up. And then when you've done that, exactly same method again, you'll take a centimetre of good solder braid on there. You'll whack a little bit of flux, so it's a dot of flux. Clean bit, little dab of solder on that, let the heat go in, yeah. That's how you clean a BGA for reballing. Then, of course, after that, what I normally do is after that, I actually that little plastic tub you saw me with, I fill that with isopropyl alcohol and throw this into it normally. And just let it soak in it for a little bit, and then use a brush on it, and then just dry it with a bit of kitchen roll. But I just want to show you that's how you clean out the BGA for reballing. So really, it's quite ironic, isn't it? We didn't get. That's still sticky. I wanted to show you that. Okay, plastic tub, BGA, flux. Not flux, sorry, isopropyl alcohol, and clean it. Yeah, that's how we clean one of them up. Yeah. That's how you clean one of them up. A little bit sticky stuff stuck to it still there. Come off. Yeah, so rather ironically here, we've trashed the BGA, yeah, because it's got too hot, but we still haven't got enough heat into one corner, and we haven't damaged any of the pads on the trashed BGA. We've damaged the pads on the board. That's sod's law, isn't it? Okay. I'm going to upload this video because I'm trying to make a reality TV. I want to show you guys. Yeah, you can go and find lots of videos that will show you how this is done. It'll be perfect every time, but I'll guarantee you it ain't, unless those guys are just that much better than me, or got better equipment or techniques. You know, maybe I'm certainly the best at this. But yeah, there you go. So this is scrap. We could have bought a BGA for €8, but there's no point. But we've still got lots of FETs and capacitors and things on here. And what we've also got on here is the ROM. So the next thing I'm going to do, we proved the short it was there. The next thing we're going to do with this is remove the ROM chip, yeah. And we're going to remove the ROM chip off the other non-working board. We're going to put them in the EEPROM program, and we're going to have a look to see if they're the same. And if they're not, we're going to copy this ROM onto the other one. Or for that matter, just stick it on there, because we can hopefully put it back on there. Okay guys, hope you enjoyed the next step. I'm sure there was plenty to learn there, even if it didn't go well. And I will see you on the next video. With this one, we'll get onto that ROM and we'll see what we can do with it. Cheers, see you soon.